Hi and welcome back. So we've seen in the previous video that the growth rate of output per worker is ultimately determined by the rate of technological progress. What we haven't discussed so far is where does the technological progress itself come from, or where does technology come from? So in this video we'll be basically answering the question that what determines the rate of technological progress. Given the critical role that technological progress plays in ensuring sustained economic growth, it is therefore important that we understand the factors that determine technological progress. So when we think about technological progress, what comes to mind, or a picture that comes to mind, is image of major discoveries. Discoveries such as the intervention of the microchip, the discovery of the structure of DNA, and the discovery of computers, smartphones, and nanotechnology, which is used in fiber optics, which then makes it possible to transmit pictures and other media contents via the internet and many other applications. This is not a new subject to our daily life, especially since we live in the times of 4IR, where we see most of the things and most of our daily activities and social life being through means of technology and applications. So these discoveries suggest a process driven largely by scientific research and chance rather than by economic factors or forces. So the truth of the matter, though, is that most technological progress in modern economies is as a result of a humdrum process, that is the outcome of firms' research and development, or rather R&D activities. So industrial research and development expenditure basically accounts between 2% and 3% of GDP in each of the four major rich countries we looked at in chapter 10. For instance, about 75% of the roughly 1 million US scientists and researchers working in research and development are employed by firms. So this would mean that firms basically spend a substantial amount of their investment on research and development. South Africa, on the other hand, as shown by the National Survey of Research and Experimental Development, spent about 0.87% of GDP on research and development for the period of 2009 to 2010. So now, why do firms spend so much on R&Ds? So firms spend on R&Ds for the same reasons they buy machines and build new products and plants. So the fact that a country like South Africa doesn't spend much on R&D, or rather on research and development, would suggest that innovation of new products will be, or technological progress will be very less in that particular country, and subsequently the total productivity of that country. So as we said, firms invest more on R&D for the same reasons why they invest on machines and new plants, basically to increase their profit. So by increasing spending on research and development, a firm increases the probability that it will discover and develop a new product. So what does this mean? It means that if a new product is successful, the firm's profit will basically increase. There is, however, an important difference between purchasing a machine and spending more on research and development. The difference is that the outcome of research and development is fundamentally just an idea. And unlike a machine, an idea can potentially be used by many firms at the same time. A firm that has just acquired a new machine does not have to worry about another firm using that particular machine at the same time. A firm that has discovered and developed a new product can make no such assumption. So this last point implies that the level of research and development spending depends not only on the fertility of research, or that is how spending on research and development translate into new ideas and new product, but also in the appropriability of research results. So that is the extent in which firms can benefit from the result of their own research and development. And let's look at these two points separately. So the first point is that the level of research and development depends on the fertility of the research. So this refers to how spending on research and development translate into new ideas and new product. And appropriability of research results basically suggests the extent to which firms that have made financial outlays concerning research and development are able to recoup their investment and make good returns out of it. So it's basically benefiting from your own research and development spending. The appropriability of research result is pretty straightforward. It basically states, or rather suggests, that if firms cannot appropriate the profit from the development of new products, they will not engage in research and development, and technological progress will be slow. So for this particular point, the nature of the research process itself is very important. So what needs more explanation is the fertility of research. So the fertility of research basically suggests that if research is very fertile, that is, research and development spending leads to many new products, then other things being equal, firms will have strong incentive to spend on research and development. That is, research and development, and by implication, technological progress will be high, simply because they are, in actual fact, gaining returns from their investment. However, the factors that ensure that fertility of research is prompted are mostly outside of the confines of economics, or rather the determinant of fertility of research are mostly outside of the confines of economics. So what determines fertility of research? So one, fertility of research is determined by a successful interaction between two factors. One, basic research, that is the research for general principle and results. And two, applied research and development, which is the application of this result to specific uses and development of new products. So basic does not lead by itself to technological progress, but the success of applied research and development depends ultimately, or rather largely, on the basic research. So basic research translates into applied research and development, and that will translate into technological progress. For example, much of the computer industry development can be traced to a few breakthroughs. For instance, from the intervention of transistor to the intervention of microchip. So some countries appear more successful at basic research, and other countries are more successful at applied research and development. So studies point to differences in the education system as one of the reasons why. So this means that some countries have an education system that teaches people to be more application driven, and some to be more theory driven. Studies also point to the importance of a culture of entrepreneurship, in which a big part of technological progress comes from, which is the ability of entrepreneurs to organize the successful development and marketing of new products. So this means that education and the culture of entrepreneurship plays a crucial role in the overall technological progress. This is pretty straightforward, since it's understandable that more educated people can use more complex machines and handle more complex tasks. So therefore, human capital development support leads to better researchers and scientists, and by implication, higher technological progress. So the key points factors here are around science and education, and these are associated with human capital. Hence, the role of human capital as a driver of research and development. So let's look deeper again into the appropriability of the research process. As we said, this simply suggests that if firms cannot appropriate the profits from the development of new products, they will not engage in research and development, and technological progress will be slow. So many factors are also at play here. So the nature of research process itself is important. For example, if it is widely believed that the discovery of a new product by one firm will quickly lead to discovery of an even better product by another firm, there may be likely payoff to being first. So in other words, a highly fertile field of research may not generate high level of research and development because no company will find the investment worthwhile. So what's even more important here is the legal protection given to new products. So legal protection to safeguard one's discovery are essential in encouraging firms to invest in research and development. Because without the legal protection, the profit from the research and development investment will be less attractive. So patent laws provide firms with the required legal protection to benefit from the research and development investment. That leads to new techniques, devices, and the right to exclude others from the production and use of the new discoveries from a specific period of time. For example, a big pharma spends on biogenetic research and development to identify new drugs because of the profits that can be attained for the new drugs. So too stringent policy on legal protection would stifle effort to build on previous research and development. And too little legal protection will reduce intensive for research and development spending. So there has to be a sensible balance of protection and access, particularly to transform basic research findings into applied research outcomes for faster technological progress. So basic example of this is what you may have seen with the access to downloading music and movies and textbook. And these softwares are basically not always free, and even though they are accessible to a certain extent. Okay, so we can now use the theory we have developed in this and the previous chapter to interpret some of the facts we saw in chapter 10 in the beginning of the course. And we'll be doing that in the next video. Thank you.